Hello everyone, my name is Jeffian Lin and I'm from National Sannyasin University. In this video, I'm going to introduce two topics, which is the inverse eigenvalue problem of a graph and the zero forcing. The inverse eigenvalue problem of a graph is saying when a graph is given and we are going to look at all the weighted adjacency metrics of the graph. And so here star is a non-zero entry and the question mark can be any real number. And suppose that's all the information that I give you, then what can you say about this matrix? The rank, the nullity, and the spectrum. On the other side, the zero forcing number, or zero forcing, is a color change process. At the very beginning, we will color every vertices. Some of them will be colored blue while others are white. Okay, and we are going to use what we called the color change rule to make more and more vertices blue. And so later on, we are going to describe the color change rule and describe zero forcing in more detail and come back to the inverse eigenvalue problem of a graph and see its application. So here is the color change rule. The color change rule states that we need to find a vertex x. Suppose x is blue and all of its neighbors are blue already except for just one, and this one can be made blue in the next step. So 2 will make 1 blue and 3 will make 4 blue, and later on 4 can make 5 blue. So you will see that 2, 3 is a good choice, but 2, 4 or 2 itself is not a good choice. So zero forcing number z of g is try to find the minimum number of blue vertices that is required at the beginning to make the whole graph blue. Zero forcing is motivated by linear algebra and quantum control, and it has applications in the control of electronic circuit and graph searching. And here, this is one of my favorite is deep connection to linear algebra. So let's look at the system of linear equation on the right-hand side, and you can see that the zero and non-zeroness of the coefficient is described by the adjacency of the graph on the left-hand side. Okay, so with this, we knew that 2, 3 are blue is enough to make 1, 4, and 5 blues sequentially. So the translation of this process is the following. If you look at this equation saying and provide that the information says that yz is equal to 0, then you can sequentially make x equal to 0 and w and u equal to 0. So zero forcing process is just a process of spreading more and more zeros. On the other hand, the inverse eigenvalue problem of a graph is a topic that describes or studies the set S of G. As described before, S of G contains all the weighted adjacency metrics of the graph G. So when G is C5, this is all the matrices. It looks like this. So when you give me a matrix like this, then I can calculate the spectrum. But if I give you a set of real numbers, and can you go back to S of G and find out whether there is a matrix whose spectrum is as desired, or there is just no such matrix? So the inverse eigenvalue problem is trying to find out all the possible spectrum of a matrix in S of G. When we talk about the spectrum of real symmetric matrix, there are several things that we can do. Because all the eigenvalues are real, then we can put it on a real line and then use the height to describe the multiplicities. So we can describe the multiplicity list, which is m1 up to mq, and we can also talk about the q value, which is the number of distinct eigenvalues. We can also talk about the height, which is the multiplicities. So the questions in concern are the following. For example, pick a matrix and pick an eigenvalue, and what are the maximum multiplicity over all such matrices and eigenvalues. And it turns out this M of G is always bounded by above by Z of G, which is the zero forcing number, a combinatorial parameter. And on the other side, we can also talk about Q of G, which is the minimum number of distinct eigenvalue over all matrices of S of G. And it turns out that there are just so many open questions in IEPG, and there's no general strategy to find out what is Q and what is M. Even for tree, there's no general strategy to find out Q of G. So if you are interested in these topics, then here is an introductory article that is published in Notices of American Mathematical Society. And if you are interested in my research, you can scan the QR code on the screen. So thank you very much.